So we've got that so far, that the acceleration is equal to the final velocity minus the initial velocity, which seems like it's going to be 10 take away 10. But remember, these are vectors, not scalars. Okay, and so what we're going to do is how do we subtract vectors? Well, what we do is we use an end-to-end. Let's start off, how do we add vectors? If I had a vector going like that and another vector going like that, then I would add them end to end, and the resultant vector would be that, right? Yeah, happy with that? Remember that? Let's in other words, let's do these with nice neat arrows. So we'll take one of these, and I'm going to make it a different color, and we're going to say that is vector A, and we're going to take another one. Oops. I'm going to take this one, and this is going to be vector D. So A plus D is, we're just going to stick them end to end. So we can just do this A to D, A plus D over here. Yeah, and that's going to be A plus D. So let's give the resultant vector a different color. Yeah, all right. So that yellow one there, that's A plus D, right? Okay, happy with that? Yeah, so you're familiar with how to add vectors. So that's how you add vectors, different to how you add scalars, right? So what about if it was A take away D? Well, if it was take away D, I would have to do a negative D, when negative D would be the exact opposite way around. Whoops. Okay, so it'd be like that, but I can't arrange it like that. I have to arrange it head to head again, like that. So, so basically, now I do the resultant of A take away D, and it's going to be that, in fact. Okay. All right. Okay, so let's do that with these v minus u. So we'll take our v vector, we'll take our u vector, we'll make u negative u, and then we'll do them head to tail. And now we want a resultant vector. Oh, come on. Right. And that's our resultant vector. Okay, that's what v minus u is, yeah? So the yellow one is v minus u. So this was v, and this is negative u. Okay. So this is very interesting. The reason why it's very interesting is because if I take this resultant vector up here and put it around about there, look, it's pointing to the center. So no surprise, because we know that the acceleration, because we would take the size of that thing there, whatever it might be, once we put it onto this little triangle, and we would divide it by time. I'm going to put it back down there for now. And we divide it by time, and that would give us our acceleration vector. So it's accelerating. Apparently, it's accelerating towards the center, even though it's not changing speed. It's not changing speed, but it's changing velocity because it's changing direction. And the direction, it's. I'm just going to check what time we got on this because it's going to cut me off mid sentence. Okay, so the time. The acceleration is going to be the size of that v minus u divided by time, and it's acting towards the center, as you can see from this one up here. And then, of course, the force that is being applied, well, we can work out the force because it's going to be the mass multiplied by the acceleration. Okay. All right, let's stop there.